Okay, so 12.5, number 40, they give us two functions. They say, okay, f of x is 2x minus 3, and f inverse of x is x plus 3 over 2. And then they want me to determine f of f inverse of x and f inverse of x, f inverse of f of x. Okay, cool?
Is that where you started?
Yeah, this is a case of you can do a bunch of arithmetic and algebra, or you can just notice something. The something you might notice is, okay, if I have a picture that looks like this, and f goes somewhere, right? Takes x's to some things. F inverse is the thing that undoes that, right? Okay, so if I do something to an x and then undo it, I should get back to where I started, right? So this x should go out somewhere and then come back. Or, well, so this one, right? This second one is x starts here, goes there, comes back, right? The other one, so this should be x. This is really the left-hand x. This will be not quite the same thing. Pictorially, that x starts over here, right? I do f inverse to it, and then I do f.
Oh, so f of x.
It's still going to be x. But what I mean is, this is kind of the x in the left-hand place, and this is the x in the right-hand place. They haven't told me those places are different, so I'm just going to assume they're numbers, right? And then these are the same thing. You guys see that? If I wanted to do this without noticing this kind of fundamental fact, I could. We could say, okay, for the first one, I want to do f of f inverse of x, right? That's f done to f inverse of x. Yeah? Okay, so I can take my rule for f, that's twice whatever minus 3, right? And then what am I sticking in for the whatever?
X plus 3 over 2.
X plus 3 over 2. Okay, so then what?
Cancel the 2's, cancel the 3's.
Okay, so first things first, I cancel the 2's, so I get x plus 3 minus 3. Then the 3's cancel, I get x. If I do it the other way, similar things will happen. Really, because a function and its inverse should undo one another. You see that? This is the problem we have with that squaring and unsquaring function, right? They're not actually inverses, so they don't actually undo each other, right? That's why I have these kind of problems where I write down square root of x squared, right? What's this?
X if x is positive.
Yeah, this is x restricted to positive. Right? If I did it the other way, right? When I take the square root of x squared, what do I get there?
Absolute value x.
Yeah, I get absolute value of x. You guys see that? Neither of these is x, because this is not a rule and it's undoing, right? It's a rule and it's almost undoing. You guys see that? So this is actually how you could tell if a function is invertible. Right? If you can find an inverse for a function, you'll be able to demonstrate that a function works like this. You could check this. So if you think you've come up with an inverse, you could compose it with the function you started with, see if you get x back, Then swap the orders, see if you get x back. If you get x back on both pieces, it worked, you found an inverse. If one of them breaks, like this, then you didn't quite find an inverse, you found something that's almost an inverse. Does that make sense?